This is TWiT.
If Google's big reveal last week of this proposed Topics API hadn't seemed like such a potentially significant event for the industry, Qualys's disclosure that same day of an absolutely pervasive, long-standing and readily exploited local privilege escalation vulnerability affecting every major Linux distribution, and it's being referred to as an attacker's dream come true. You know, if it hadn't been for Google basically stealing the topic of this podcast, that would have been the title story. This would have been the title story of the week, so-called PwnKit, PwnKit. Fortunately, we have time to discuss both, and this one is really interesting. Okay, so the Qualys research team discovered a memory, okay, it's being kind to call this a memory corruption vulnerability, as we'll see. They discovered a memory corruption vulnerability in PwnKit's Pkexec command, which is an SUID root program, which I'll explain in a second, which is installed by default in every major Linux distribution. An SUID root program is one which has its special SUID permission bit set on its file in the file system, which causes the operating system to run it under the permissions of its owner rather than the user who is invoking it. And so an SUID root program means that it is owned by the root account. And these permissions are, you know, anyone who's seen Linux, and I know you, Jason, as an Android person, are probably familiar with the way the file system looks. You know, you have read, write, and execute bits for the owner, the group, and and the object itself. And one of those status bits can be S as opposed to X, so that it says this is executable, and when you execute it, operating system, run it under its owner account rather than the user. Anyway, the point is, this is a very powerful and dangerous permission for something to have. Since Pkexec's owner is the root account, that gives it a lot of power. But actually, the point of it is that it needs to have that power. That is, the thing you do with it is about that. But it turns out that there's an easily exploitable vulnerability in this program which allows any unprivileged user to gain full root privileges for themselves on any vulnerable host by exploiting this vulnerability in its default configuration with 100% reliability. Again, it is an attacker's dream come true. It's been there since May of 2009. It works perfectly. Proof of concepts appeared within 3 hours of Qualys's disclosure. I mean, it's that easy to do. In fact, I'm going to suggest that it's a perfect, test yourself if you can invent an exploit from the description, because it's not even that hard. SANS Security Research wrote, quote, "We expect that the exploit will become public soon and that attackers will start exploiting it. This is especially dangerous for any multi-user system that allows shell access to users." Well, yeah, right, because that's all you need. And SANS expectations, as I said, were realized less than 3 hours after Qualys published the technical details for what's being called PwnKit. I have a link to the C code of a reliable exploit at the end of this story. But if you want to test yourself, don't look at it. Anyway, we'll get there in a second. The U.S.'s National Security Agency, the NSA, Cybersecurity Director Rob Joyce noted on Twitter that the bug, quote, he said, has me concerned. He said, easy and reliable privilege escalation pre-installed on every major Linux distribution. Patch ASAP or use the simple chmod 0755 with /user/bin/pkexec mitigation. So what he's saying there is fix your distro, or if for some reason you can't, then use the chmod command that 0755 sets the permissions to standard executable, not an SUID executable on that program. And he said, he finished his tweet, there are working proof of concepts in the wild. Okay, so PwnKit, which was formerly known as PolicyKit, is a component used for controlling system-wide privileges in Unix-like operating systems, most popularly, of course, Linux. The package is used for controlling, as I said, system-wide privileges. The Pkexec tool, which is a command line utility, is used to define which authorized user can execute a program as another user. And that utility has a critical flaw. Qualys security researchers rediscovered, and I'll explain that in a minute, the vulnerability, developed an exploit, and obtained full root privileges on default installations of Ubuntu, Debian, Fedora, and CentOS. Others, if not all, Linux distros are likely vulnerable and are almost certainly exploitable. Most sobering is that this vulnerability has been hiding in plain sight for more than 12 years. It affects all versions of Pkexec since its premier release in May of 2009, when the miswritten Pkexec command was first added to the PolicyKit. I mentioned that Qualys rediscovered the vulnerability. Again, I'll explain that in a second. So, as soon as Qualys' team had confirmed the vulnerability, they responsibly disclosed this glaring flaw back on November 18th and coordinated with all open source distributions to fix and then coordinate their announcement. Qualys' disclosure, I provided a link in the show notes, provides the details of the coding error that has always been present in PwnKit's Pkexec command. And frankly, it's a little bit shocking. In the C language, a command line program receives two parameters from the operating system which is launching the program. They're commonly known as, and in fact are, argc and argv. C is short for count, and V is short for vector, as in a one-dimensional vector array. So argc is an integer count of the command line parameters being passed to the program, and argv is a pointer to a vector array of pointers to strings. Now, that sounds overly complicated when it's stated like that, but it just means that argv points to a list where the various command line argument strings can be found. And argc tells us how long that list is, how many string parameters are in the list. The problem is, launching a program from a command line is only one of several ways for a Unix-like operating system to run a program. It's entirely possible for the operating system to launch a program itself. And in that case, there's no actual command line, and the operating system can determine what parameters it wishes to provide to the spawned program, if any. In other words, that list of parameters can be empty. In that case, argc, the count of parameters, would be 0. And any properly designed parameter processing logic would know to skip that phase of the program's startup, since there's no parameters to parse. So guess what mistake the original author of Pkexec made back in May of 2009? He completely failed to take into account the possibility that Pkexec, this very powerful program that always is run by the operating system as root, failed to take into account the possibility that Pkexec might be started without any parameters. He never checks to see whether argc is 0. His code mistakenly assumes that parameters will always be present, so it doesn't check. It just jumps right into dealing with the items in the non-existent list of parameters. Ouch. And it turns out that mistake can be weaponized. And when it is, it's 100% reliable and even cross-architecture, also working not only on x86 and x64 Intel architectures, but also ARM64 systems as well, which was confirmed by the CERT Coordination Center's vulnerability analyst Will Dorman. Red Hat described it this way. They said, quote, "The current version of Pkexec doesn't handle the calling parameters count correctly and ends up trying to execute environment variables as commands," which is a clue to how you exploit this puppy. They said, "An attacker can leverage this by crafting environment variables in such a way it'll induce Pkexec to execute arbitrary code. When successfully executed, the attack can cause a local privilege escalation given unprivileged users administrative rights on the target machine." Okay, so yikes. Again, all Linuxes everywhere for the last 12 years trivially, locally escalated a non-privileged user to root. Since most major distributions have already released patches and updates, the best option now would be to install the patches for your version of Linux. If that's not immediately feasible for any reason, or if there are no patches available for your particular distribution, as the NSA themselves mentioned, the vulnerability can be prevented from being exploited by removing the SUID bit from the Pkexec utility's OS file privileges, and then verify that nothing important has broken by that change because maybe it was actually being used by your system. So that can be done by using the chmod command with the -s or -s flag to remove the S privilege, or by following, the NSA's chmod of 0755. And anyone who doesn't know what any of that means doesn't need to worry about it, because you shouldn't go there. You should just update your Linux version. For anyone who's interested in the sort of, in this sort of hack development, I really think this would be a perfect learning opportunity. The Qualys disclosure provides beautiful technical details, deliberately stopping just short because they didn't want to go all the way. They did themselves, they just didn't publish it, of providing a working proof of concept. So perhaps take what Qualys provided and try your hand at turning that into a working exploit. It's open source. You can Qualys provides snippets. You're showing the answer. It's open source. And Qualys provides some even highlights the high points, although anybody who is a C coder who's heard what I've said has already been rolling their eyes, and you'll instantly see in the source where the problem is. There is a well-written proof of concept, fully working exploit that is completely usable, and I do have a link to the C code of it in the show notes. But if you want to see if you can do this yourself, it is, again, and if you got some time, you like to play, here's a vulnerability that is just waiting to be exploited. And the answer is also available. And remember I mentioned it was rediscovered? This is hard to believe, but Qualys was not the first to discover exactly this problem with PwnKit's Pkexec command. It was originally discovered and blogged about in full by an Australian hacker living in Sydney by the name of Ryan Mallon. And he blogged about it on December 16th of 2013. So, yeah, 8 years ago? Or 9. Ryan's WordPress blog post was titled ArgV Silliness. And he wrote, he said, most C programmers should be aware that the argv argument to main, which is, the master routine of any C program, is a null-terminated list of strings, where the first element is the name of the program. On Linux, there's an odd feature, he has in quotes, which allows the list to be empty. From the Linux execve man page, and he cites it, it reads, on Linux, argv can be specified as null, which has the same effect as specifying this argument as a pointer to a list containing a single null pointer. It says, do not take advantage of this misfeature. It is non-standard and non-portable. On most other Linux systems, doing this will result in an error. And it says, e-fault. So then Ryan continues, this allows us to execute an application with argv 0, meaning the 0th array of the element equals null. Many applications, including several setuid applications, make the assumption that argv of 0 is always a valid pointer. While I haven't found any potential exploits using this, it does allow for some amusing behavior from setuid binaries. And then he goes into some further detail, and then he actually landed and talked about the same exploitable. He wrote, after searching around on a stock Ubuntu system for setuid binaries that looked promising for passing argv of 0 equals null, I found Pkexec. Pkexec is part of the PwnKit package, which allows a binary to be executed as another user, similar to sudo. We call execve, and that's a Linux API used to programmatically execute another program, passing an empty argv list and a single dummy environment variable. And then he goes on. So anyway, it was originally discovered. Ryan blogged it. He explained it completely. He didn't go to the trouble of weaponizing it. But then it sat there until late last year when Qualys also discovered it. And, being security people, like very capable security people, they said, oh, we know how to weaponize this. And they did. And now everybody has it. So we have another example of Bruce Schneier's sage observation that attacks never get worse, they only ever get better. And this one was a doozy. So again, not remotely exploitable. Bad guys in, China or Russia or whatever foreign country, can't get into your machines this way. But if anything is unprivileged on your machine and untrusted, and you haven't fixed this, I mean, it's already it instantly jumped into the attacker's toolkit. If they ever find themselves on a Linux machine, the first thing they're going to try to do is see whether they can use this hack to elevate their privileges to root. So you want to make sure that any systems that you're responsible for have been updated to fix this. I mean, it was such a simple thing to fix, but it's been broken for a long time.
And discovered so long ago. Poor Ryan. Ryan
Yes.
blogs about it. Like, hey, everybody, check this out. Can you imagine? Can you believe what I found? Crickets. I mean, I'm looking on the post, and like any of the comments have happened in the last few days. Like, obviously, no one came across this post and really,
Right.
you know what I mean? Or if they did, they didn't mention anything about it because, hey, let's keep this hidden. Let's keep this a secret.
Well, and one wonders, doesn't one?
Yeah.
It's like, did the NSA say, hey, this is handy. Let's use this.
Right.
And then as soon as the world finds out about it, turn it off.
I don't know. We better get rid of it. Yep, totally. Who the heck knows? Anyways, good on you, Ryan.